Welcome to Strength of Material Lectures by Civil Thinking, and in this class we are going to solve a problem on internal force in trusses and frames. The problem is on your screen. A plane frame is restrained at joint A and C. Okay, here is joint A which is fully fixed, and there is joint C which is also fixed, but here is a roller. Okay, now member AB and BC are pin connected at B. Now at B here is a pin connection. Internal pin is at B. Okay, this is BC and this is AB, right? They are like two rectangular bars. They are connected here with the help of a pin. Now a triangularly distributed lateral load with a peak intensity of 1300 Newton per meter acts on AB. Now in this frame the triangular load acts uniformly. Varying load acts at A, the intensity of load is 0, and at B of this frame the intensity is 1300 Newton per meter, right? Now a concentrated moment is applied at joint C. Now in this frame at joint C, joint C is part of BC member, right? At joint C of this beam there is a moment of 680 Newton meter acting. Now the problem is find reactions at supports A and C. Okay, we have to find the reactions at A and we also have to find the reactions at C, right? Now A and C are supports. Now let's first know how many reactions are at A and how many are at C. We'll write them down here and find them one by one. Okay, now this is a fixed, fully fixed. Okay, this is a fully fixed. It means there is no rotation. Okay, it means there will be a movement. There is no possibility of upward movement or downward movement. It means there will be a vertical reaction, and here will be no horizontal movement too, right? It means horizontal reaction too. Okay, so if I erase this, okay, now I can write here AY. Okay, so let me first draw a axis. Okay, this is x-axis and this is y-axis. Okay, what does that mean? If there is a force in x direction, okay, in this arrow it is going to be positive. Okay, and if there is a vertical force anywhere up in upward direction, it is going to be positive again. Okay, and if there is going to be a force like this, okay, now this is a horizontal force but it is against the direction of this arrow. Okay, so this is going to be negative. If there is a force like this, it is in the x direction but it is the direction is same as x, so it is going to be positive. And if there is a force like this, what is this? It is a vertical force and the arrows are heading towards upwards, both have the same direction. This is going to be positive. And if there is force anywhere in this truss like this in the downward direction, okay, it is going to be negative. Why? Because y vector is acting upwards and our force is in down direction. Okay, anyways, now here is going to be a y, here is going to be, let me assume the horizontal direction ax. Okay, ax for in the x direction, okay, horizontal direction, ay for vertical y direction. Okay, now here is also going to be a movement. Okay, let me assume movement at a in this direction. Okay, I assume the movement at a is in the anti-clockwise direction. Again, if there is a clockwise movement, I am assuming it to be positive, and if there is an anti-clockwise movement, I am assuming that to be negative. You can also assume the opposite. You can assume this to be positive and this to be negative, as long as you follow the same sign convention. Okay, whatever the sign convention you follow, if you follow the same sign convention from the beginning to the end of the problem, you are good to go. But you cannot change the sign convention in between the problem. Okay, now anyways, now here is at C, here is a support 2. Now it is a roller. Roller means it's free to move in the horizontal direction. It means there will be no horizontal reaction at C in this frame. Now also in this frame at C there is a vertical reaction, okay, because this will not let it move in the vertical direction. And also here is a pin, okay, this is a pin, the point means pin. Pin means there is no movement, okay. So at C we only have one reaction, right? So let me assume the direction like this. Let me call this as CY reaction, okay. And anyways, if we get the I assume the AY to be upward, AX to be towards left, CY to be upward. But keep in mind, when we find the numerical values of these, if we get the same value, I mean if we get the positive value, that means our assumed direction is right. And if we get the negative value, that means our assumed direction is wrong and the actual direction is opposite to the assumed direction. Anyways, find the support reactions at support A and C. So how many are the support reactions? So let me write here. The support reactions are AY. Okay, I have to find AY. I have to find AX. Right, I'll write here. And I have to find CY. Okay, and I also have to find moment at A. Okay, moment at A. These are all the support reactions, okay. Now let's find them one by one. Now how do we find the support reactions? We find the support reactions with the help of equilibrium equations, okay. Equilibrium equations, okay, because this is a 2D frame, there will be three equilibrium equations, okay. Now again, if you don't know about what is the 2D frame, what are equilibrium equations, please watch my previous video lecture and you will understand why there are three equilibrium equations in a 2D plane, okay. Now anyways, what are those? They are summation of fx equal to 0, summation of fy equal to 0, and summation of moment equal to 0, right? Now let's first apply this summation fx equal to 0. Now look at this frame, okay. You have to see the horizontal. X means horizontal, right? X-axis is the horizontal axis. So summation fx equal to 0 means summation of all the forces in the x direction or in the horizontal direction are 0. It means we have to sum up all the forces in the horizontal direction and equate them to 0, okay. Now at A, at B, at C, you have to see the horizontal forces, okay. Or also this is a load, this is also horizontal, it will be considered too, okay. Now before I apply summation fx equal to 0, let me first talk about this, okay, lateral load. Now you can see in this frame there is acting a uniformly varying load. At A the intensity is 0, okay, as you can see, and it is increasing as we move towards the B, and B is the highest, okay, highest intensity of load is 1300 Newton per meter, okay. Now this is the load intensity diagram, okay. Now if you want to find the resultant load due to this load intensity diagram, which is a uniformly varying diagram, the area of this intensity diagram will give you the load, okay. So if I find the area of this triangle, okay, the base is 3.7 meters, right? This is 3.7 meters from here to here. It means from here to here is 3.7 meters, and the perpendicular of this triangle, okay, is 1300, okay. Now we know the area of a triangle is how much? One half of base is 3.7 meters multiplied by perpendicular, which is 1300, or we also call this as normal. Anyways, 1300, how much is it? 2405 Newton, of course. Now why it is Newton? Because 3.7 is meters, right? Now 1300 is Newton per meter, okay. Now meter and meter cancels out, we are left with only Newton, okay. That's why here is Newton. Now anyways, the resultant load due to this load intensity is 2405. It means we can just erase all of this and replace this with one single vector point load. of 2405 Newton. Okay, but the question is, where are we going to place that point load due to all of this? Will it be here, will it be here, or where? The resultant load will act at the center of gravity of this triangular load. Okay, and we know, let's suppose, let me erase this. Let me suppose this is the center of gravity. Okay, now from here to here, okay, from here to here, it is going to be one third of 3.7. Okay, it is going to be one third of 3.7, and from here up to here, it is going to be two-thirds of 3.7. Okay, I think this is the basic trigonometry. You might know this. Okay, so let me calculate this. One third of 3.7 and two-thirds of 3.7, and the load will act here, right? So we are going to erase this triangle. We don't need this triangle anymore. Two-thirds of 3.7, right, from here to here. So let me calculate these values. Okay, now two-thirds of 37 is, I found it is 2.46 meters. So from here to here is 2.46 meters, and one third of 3.7 is 1.23. Okay, so let me erase this. It is 1.23. 1.23 meters. Okay, now there is this too, so we can write 2405 Newton. Okay, here. So let me erase all of this. Now I will apply summation fx equal to 0. Now in the x direction there is an ax which is opposite to this direction, right, which means it is negative. Okay, which is minus ax. Now here is a horizontal force again in the x direction, which is in same direction as x-axis, so it is plus 2405. Is there any another horizontal force? No. So let me equate it to be 0. So from here we will get ax how much? 2405 Newton. Okay, so we found ax. Okay, let me write here 2405 Newton, right? So we have applied summation fx equal to 0. Now let's apply summation fy equal to 0. Now fy means y is in the vertical direction, means we have to sum up all the forces in the vertical direction and equate them to 0. Now ay, it upwards. Okay, now the y-axis is upwards, same direction, so ay is positive. Here is another vertical force cy, it is upwards, and y-axis is upwards too, and this is also going to be positive, right? So when we apply summation fy equal to 0, we will get ay plus cy. Is there any another vertical force? No, so it is equal to 0. Now this equation will not yield us anything right now, okay, but it will be very useful later on. So let me call this as equation first. Okay, now we have also applied summation fy equal to 0. Now we are left with summation m equal to 0. Now before I apply summation m equal to 0, to simplify this frame, I will split the frame. Okay, I will draw the free body diagram of AB and BC. Okay, because this frame is made of AB and BC, which are connected with pin, right? What I'm going to do, I will break the pin. When I will break the pin, they will be separate, right? So let me draw the free body diagram of AB separate and BC separate. Okay, this is A, this is B. Now here is 2405 Newton. Okay, from here to here is 2.46 meters. From here to here is how much? 1.23 meters, right? Now let me also, this is AB, and I also have to write the reactions. Let us say this is AX, but we already found AX to be 2405, so I will just write 2405 Newton, of course. Now here is AY. Now here is moment at A, right? So I'm going to draw like this. This is moment at A, okay? Now I think I write all the details of AB element, okay, which is actually a column, by the way. Okay, now let me first draw the BC first. This is the free body diagram of BC element of this column. Okay, let me say this is B, this is C. Here is a moment, as you can see it is 680 Newton meter. Here is an upward reaction which is Cy. The total length is 2.75 meter. Okay, I think that's all in BC, right? Now we also have to find Cy. Okay, now here is the trick. I mean, here is why we did this. We will apply summation m equals 0 on BC or AB or both, okay, so that we can find our unknowns. Okay, now if you will see in BC, if you apply summation of moment at B equal to 0, okay, summation of moment at B equal to 0, what you are going to get? Now at B there is a moment due to Cy in the anti-clockwise direction, and anti-clockwise direction is negative, so I'm going to write minus Cy. How far is it from B? 2.75. Okay, now here is also a moment of 680 Newton. Okay, now we are finding moment at B. Now there are some students who do the problem, who do the mistake thinking that no, the moment is acting at C, so I will not write it at B. Okay, because we are finding moment at B, but this moment is at C. No, you have to keep in mind, if there is a moment in this element in any column or frame, if it's acting at one point, it means it's acting everywhere. Okay, so at B this moment also acts, it acts everywhere. Now 680 is, what is this direction? It is clockwise, so I'm going to write plus 680. Okay, it is going to be 0, right? Because summation moment equal 0. Now from here we will get Cy. Okay, let me write here, Cy is going to be how much? Minus 680, right, divided by 2.75. Okay, this is Newton meter and this is meter. Okay, meter and meter cancels out, we are only left with Newton. Okay, now 680 divided by 2.75 is how much? 247.27. Okay, so we found Cy to be 247.27 Newton. Okay, so I will write here, we found Cy to be 247.27 Newton, right? Now okay, we found this AX, we found the Cy, we also have found AY, right? How do we find AY? Now we know the Cy. I told you before, this equation is important. Okay, we've got this equation due to summation Fi equal to 0. Anyways, we have applied this. Now from this equation we are going to put Cy. Okay, here the Cy is 247.27 Newton, right? Okay, before I move on, I would like to tell you, here is a PDF. I have solved this problem and I have placed the PDF in the description. You will find the link to download the solution. But before you download, please watch this class very carefully, because in the PDF I cannot write all the things. Okay, I cannot write so many things. I have provided the solution, but this class will very well explain the problem, and because when if you will understand this problem, you can solve any other problem on frames or trusses. Okay, now, so first watch the video lecture very carefully and then download the PDF. Okay, now we put the CY, right? By the way, CY was negative, right? Negative. This is 247, right? Now from this equation, when you put this CY to be 247.27, you will get AY to be negative 247.27 Newton. Okay, now we already also found the AY, which is negative 247.27 Newton. Okay, now we found this negative. AY is negative. What does that mean? It means the AY is not in upward direction, it is in the downward direction. Okay, anyways, now we found AY, AX, CY. We have to find MA. Okay, moment at A. Now if you look at the free body diagram of AB, here is MA. So what I'm going to do, how I'm going to find the moment at A? See, obviously you will find the moment by applying the moment, right? The moment equation. So again I am going to apply the moment equation at B. Okay, but previously we applied moment equation at B, of course, but in BC. Now we are going to apply moment at B again, but in column AB. Okay, so let me erase all of this. So let me write here, summation moment about B is 0 in AB, right? In AB, keep in mind. So it will give us what? Now moment at B is 0. It means this is the 2405 horizontal force, right? Horizontal reaction at A, and it will impose a clockwise moment, right? If you see like this, it is going to exert moment at B like this, which is in clockwise direction. Okay, so this will be positive. So the load, so the moment at B due to this 2405 is how much? 2405 multiplied by the distance from B is how much? The total is 3.7, so it is 3.7 meters. Okay, now 2405 is Newton, it is, this is meter. Okay, okay, is there anything? Yes, there is an anti-clockwise moment at A. Okay, and I told you if there is a moment at any point, it means this moment is everywhere in AB. Okay, so this is an anti-clockwise direction basically, so it is going to be negative minus MA, right? So we have already applied MA. Now this is AY, but it is passing through B, so there will be zero moment due to AY. Okay, now here is also another load 2405, which is at a distance of 1.23 from B. Now 2405 will exert moment like this, right? Which is anti-clockwise. Okay, which is negative minus 2405 Newton multiplied by 1.23 meters. Okay, it is equal to 0. Now when you will rearrange this, what you are going to get, you will get moment at A to be 2405 multiplied by 3.7 minus 2405 multiplied by 1.23, right? Now when you will solve this, you will get moment at A to be, okay, Newton meter. Why Newton meter? See, this is Newton meter, this is moment is Newton meter, this is meter, this is going to be Newton meter, so this is why it is going to be Newton meter. So we found moment at A to be, let me rub this here. So we also found moment at A to be 5940.35 Newton meter. Okay, did we find everything? Yes. Anyways, we have solved the part A of this problem. Okay, now we have to solve the part B. What is the part B? Part B is find internal stress resultants N, V and M at x equal to 1 meter on column AB. Okay, now in this frame AB is the column, okay, because vertical members are columns and the horizontal members we call them as beams. Now AB is a column, and from x at x equal to 1 meter, okay, x equal to 1 meter, okay, from A up to 1 meter, it means something here, okay. At here we have to find what? N, V and M. Now what is N? N is the normal force, okay. N is the normal force. Let me write it like this. N. V means the shear force. Let me write it here. This is V. And M, okay, here is also going to be some moment. Anyways, don't worry, I will write a clean diagram as you can see here. Now the question is find internal stress resultants on column, okay. It means we will just need this diagram, okay, we don't need this beam diagram. So let me erase everything, and after that let me find NV and M, okay. Now in this column we have to find internal stress. Now what is stress? Basically internal stress, basically it means we have to find the load at x equal to 1 meter, okay. From here to here is 1 meter, okay, x equal to 1 meter, okay. I'm talking about this, okay. We have to find n, normal force at x equal to 1 meter. We have to find the shear force, which is denoted by V, and there is also going to be some moment, okay. We can assume any direction, okay, we don't worry about that. Let me assume anti-clockwise direction, and let me denote the moment by M, okay. Now we have to find the shear force at this point, right? Let me call this point as Q. At Q we have to find V, we have to find N, and we have to find M, right? Now first V is the shear force. How are we going to find the shear force? When we apply summation of Fx equal to 0, okay. All the horizontal forces, their sum is 0, okay. So it is going to be minus 2405, okay. Is there any other force? Yes, there is V, which is in right direction, okay, right direction, which is positive, plus V. Is there any another horizontal direction? Is there any force in AQ? No, so it is equal to 0. So we get shear force to be 2405 Newton, right? So we found V to be 2405 Newton, okay. So let me rub all of this. Now we have to find N. N means the normal force. Now see, N is in what direction? N is vertical, okay, means in the Y direction, because Y is vertical. So we will simply apply summation Fy equal to 0. Because N is in the vertical direction, we are going to apply equilibrium equation in the vertical direction. Now N is downwards, opposite to this, so it is going to be minus N. Now here AY is upwards, and how much is AY? Minus 247, okay. First let me write AY is upwards plus AY. Is there any upward force? I guess no, so it is 0, okay. So minus N plus AY, how much is AY? Minus 247.27, right? Minus 247.27 is equal to 0. So from here you will get N to be minus 247.27 Newton, okay. So you get N to be 247.27 Newton, okay. Now let me rub all of this. Now we have to find moment at x equal to 1 meter, okay. Now again, diamond cuts the diamond, iron cuts the iron. We are going to find the moment with the help of the moment equation. So let's find the moment, this M, okay. Now this moment M is equal to how much? Now first of all we will consider we will consider AQ. Okay, now first of all, here is MA, right? Moment at A, which is 5940, but MA is anti-clockwise, which is going to be negative, right? Minus 5940.35. Okay, because we found MA before. Now this 2405 is going to impose clockwise movement, right? So it is positive, plus 2405 multiplied by, where are we finding, at x equal to 1 meter, so it is multiplied by 1. Is there any another moment? No, so this is equal to 0. Now when you solve this, you will get minus 3535 Newton meter. Okay, so we also find this moment. Okay, I hope I did every calculations right. Please check my calculations, okay, because sometimes I do mistakes in the calculations, and I hope you understand the concept, the basic concept. The intention of this video lecture is to give you the concept, okay, and the understanding of how we are going to solve such kind of problems, the internal force problems in frames or in trusses. And we also find the internal stresses, we find the shear force in the beams, how to find the shear force in beams, how to find the normal force in beams, how to find the bending moment in beams, okay, in columns. You will get enough concept from this video lecture. Again, if you want to download the PDF, it is in the description. And if you have any problems, if you do not understand anything, please contact me. And also, if you need tutoring, in any of the civil engineering subjects or strength of materials, okay, I definitely provide the I also provide the online lectures in strength of materials. You can also contact me for the tutoring in strength of materials. And that's it for today. See you in the next class. Thank you.